Okay, hi everybody. Thanks for being here. I'm going to go ahead and share charts to both introduce the breakout and to take notes in real time. Everybody's worst nightmare, taking notes in front of a bunch of people. I'm Kelsey Young. I'm the moderator for this breakout. Tess Caswell is here. She will be the facilitator. She is an EVA engineer down at Johnson Space Center. Thanks, Tess. And then want to give a shout out to Zach Morse as well, who's been helping take notes for this topic for yesterday and today. So thanks for all your hard work, Zach. This should be old by now because you've probably seen this about 4 times. But community participation is vital. Looking forward to hearing from all of you, hopefully. To participate, please raise your hand in Teams. Look for the little hand icon. That seemed to work pretty well in the breakout I was in yesterday. So let's keep that ball rolling. And I'll call on you in the order that you raised your hand. You can also chime in via the Teams chat if you want. If there's a ton of chatter going on in the chat, I'm going to be relying on Tess and Zach to help make me aware of that. And with that, I'll put up the leading questions again, which is really focused on how the science team is going to be structured to support operations. So while infrastructure is focused on what kind of software and physical infrastructure and data management architecture and infrastructure there needs to be, this one's focused on how the science team will be structured. And we've heard a lot about that from the talks over the last 2 days. So I'm hoping there's going to be a lot of fodder for conversation. So I want to start by showing this figure one more time that Alex briefed yesterday. And Mike, I see your hand. Let me just get through this one thing. Show you the structure that Alex briefed yesterday. So, feeding forward to the crew on the lunar surface, you have everything sort of managed by a flight director, feeding down to the person who's actually talking to the crew, which we'll get into because we've heard a lot about this SciComm position. This EVA person that sits in the FICR, the front room, that then feeds to the systems person dealing with the suit, the task person dealing with the activity that the crew member is doing, and then this EVA science officer position who's backed up by some TBD structure of science support. So it's this basic side of this chart that we kind of need to map out today. And so I really want to, come out of this breakout with all the ideas on the table for the ways of structuring this line and block diagram. Mike, did you have a question on this before I keep going?
Nope, I'm ready to talk when you are.
Okay, great. Okay, I'll call on you first. Stand by. So I dove into a few more sort of points to get the ball rolling. And I kind of split things out into sort of 3 main categories of discussion, thinking we could spend kind of equal parts of this hour on all of them. So the first one is roles and responsibilities. So what are the overall responsibilities of the science team? Are they just, executing the objectives as handed to them by somebody else, or are they involved in planning traverses, defining science objectives? What is the sort of magnitude of responsibilities that the science team needs to have? How does the broader science team interact with all the other teams within MCC, and how do they interact with the payload teams? Is the payload team part of the science team? How do we want to handle that? How do we encourage and facilitate participation of the next generation? We want to make sure that early career folks can get involved. How can we communicate with the broader science community? I mean, there's only going to be so many slots available for the real-time Artemis science team. So how can we make sure that we are inputting information and opinions from the broader science community? Is this going to be structured like this? There is a subset of people who span multiple Artemis missions with participating scientists cycling in and out, or kind of what's an ideal structure to onboard and offboard people? The second high-level topic is science team structure. And so this is, I think, the meat of what we want to talk about today. So how many sub-teams are there? Is it divvied out, like we heard from Laura and Edgar yesterday, of a sedimentation stratigraphy team? Like for the moon, would we have a volatiles team and an impact cratering team? I'm making these up wildly. Is there a samples team? Is there a handheld spectrometer team and then a GPR team? Is there a human research program or biological sciences team? What is that sort of org chart? Who are all the components and people that need to be involved, and how many people should there be? From a comms perspective, how should the science team interact and communicate during a mission? Who holds the final decision-making authority for science decisions? If a deviation to the traverse plan is put into effect, at what point does that decision need to be codified? How does the science team communicate with the crew? That's come up a lot. This idea of a CAPCOM versus a SciComm, and how many comms loops and what are those loops that are needed to facilitate science. So this is just some broad thoughts to get the ball rolling. And I think what I'd like to do is start with roles and responsibilities and spend, a third of the time on that and then move on. So moving into roles and responsibilities, I have one finding that we recommend avoiding the term backroom and instead choosing a name more appropriate to the highly integrated nature of lunar surface science operations. I haven't heard anyone disagree with that, but let me know if you do. And then I just captured a few things to get the ball rolling. Jen Heldman gave a talk that included a few specific recommendations for the R&R conversation. And I wanted to call out the next gen involvement and the broad lunar science community involvement. Just to get the ball rolling, what do we think about kind of roles and responsibilities? And do you have any suggestions for kind of like this high level category? And Mike Evans.
Okay, I'm going to start this. Alex's org chart is clearly geared towards human EVA traverses. I don't have a negative comment on that. However, I do have a very strong comment that geoscience support needs to be an SME in a FICR position. It needs to be independent of the EVA console. It needs to be dedicated to science questions regarding geologic and geophysical sciences. Unless you want to go out and start coordinating with life sciences and material sciences, we keep using this word science. Science is too broad. We are geoscience, and we are a dedicated position with a requirement to have direct access to flight and Capcom in the front room. And I'll open that as my opening position.
Any responses from the group? Yeah, I think there's a difference there. Yeah, Alex, go ahead.
No, I was just going to say I agree with Mike that especially for IVA operations, there may need to be a more involved role with some of the sciences. One thing that it's very clear from listening to all the Apollo missions and the backroom chatter, which I'm all for getting rid of the backroom call. I think like more of a science evaluation room or something set up like the MER is much more appropriate. But you can hear all the comm going back and forth, airwaves, not even on the loops that's going back and forth. And that could be very detrimental to a risky position, a risky scenario where you have crew out EVA. And so my big push is for a integrated story where you have when you're out EVA, which that's what I'm referring to. Like I said, I agree with Mike's role from an IVA perspective, but when you're out EVA, recommending hey, we recommend going after this science objective based off of these EVA consumables and this EVA timeline. If you show up to the flight director with an unintegrated story that hasn't been well vetted, then it's just going to be a mess in the front room. And it's going to take a lot of time, a lot more time than an integrated story that is well developed, well thought of when the teams are actually synced up. And that's our plan for training too, and it's purely based off of Apollo lessons learned and our success in shuttle and station is that an integrated story from the very beginning, rather than two disjointed stories going all the way up to the top, is much more efficient. And that's how it should be operated.
Alex, I totally agree with you. Bear in mind, we are also going to be doing traverses for non-human. We will do robotic traverses. And the science team also needs to coordinate logistics and consumables for a robotic vehicle that is different than the logistics we have to coordinate for human EVA. I totally agree with the human EVA side, but you typed wrong, Kelsey. Science should not be EVA FICR. Science is what I'm advocating is geoscience. And I do agree the traverse planning for a human EVA is by far, I'm going to go on a limb here, by far the most complex and required integrated role. And Alex, I think what you guys have done with all of the analog training in Desert Rats and Nemo and everything is directly relevant. However, I do not want geoscience to be stuck under an EVA console.
Thanks, Mike. Next is David Crane.
So I guess maybe to alleviate Alex's concern or rendering from the Apollo 11 film, when we were testing this in Constellation, I have to acknowledge that initially it was a little bit chaotic because, again, scientists did not have Ficker type experience. But as the simulations evolved and they gained more experience, they were fairly good in their comm capabilities. That is, they were discussing things on comm loops, their own comm loops, and doing it in a managed and Ficker-like way. Now, there were still shortcomings, which is why we had developed this initial training program for scientists who wanted to work at a Ficker-type console. And I just had to say that when we got to Desert Rats the second or third or fourth year, people were very much well behaved. And in fact, I wish, Alex, you could have seen us when we were in the MCC across the hall from the ISS Ficker. People were very well behaved, managed their comm loops, for the most part, very well.
Thanks, David. Pascal. Pascal. Okay, we'll skip him and come back. Mike Siebert.
Yeah, so Mike, and just thinking about, there was a mention of not only is the science support room, let's use that as the term for this case, going to need to interface with flight operations for the crew missions, but there was a quick mention of needing to work on robotic traverses and manage those consumables and constraints that are provided by the robotic systems. I think a thought needs to be put into how the science support room will interact with the entities operating those, because it may not be JSC. It may not actually be NASA with the push for potentially commercial procurement of the LTV or Eclipse class rover. So how this organization would interface potentially externally to NASA to those operators to achieve science objectives is a big thing to think about. And I use the global term science there because the robotics may be doing more than geoscience. They may be setting up in place infrastructure for things like heliophysics, or just to throw out an example. So I use the big word science instead of specifically geoscience intentionally.
Yeah, thanks, Mike. Pascal, see you.
Yeah, sorry, I was muted, of course. Well, first of all, I agree with everybody who last spoke. I just wanted to point out two things. One is it's very clear that in practice, for any given mission, we will have a set of science priorities, because every time, of course, we face the lunar roadmap, it's in some sense it's a there's too much to be done to be covered in any single mission, and so each mission will have presumably its set of specific high priority stakeholders, and just like in the field. For example, from our experience at HMP, but this is not new. This is true on Apollo. This is true on the MER missions and Curiosity and Perseverance. Every experiment on board has essentially a group of stakeholders behind it, and I think it's pretty clear that each one of these experiments or investigations that are sort of deemed to be the focus of that particular mission has to be represented. And of course, there will have to be arbitration from a science lead or science director. So that's the role, for example, that David played in his scenarios. But at the same time, it's clear that if you do not have an experiment that's represented on one of these missions, well, hopefully you'll have your turn on a follow-up mission. But basically, that in some sense excludes that science to be really covered or done unless it somehow is on a list of opportunistic things to sort of do on the side. But the other point I wanted to make is it's really important that we view whatever structure and architecture we sort of settle on here or that emerges from this, that it be one that it's evolvable. This goes back to the talk that I gave this morning. We want this to ultimately result in increasing autonomy in terms of tactical implementation of the field science by the team on the site, on the field crew. And this in a way that essentially will help us get ready for Mars down the road, where there will be a lot more autonomy on site. And so I view the evolution of the science operations center team, that's the term I've been using instead of science backroom, as one that essentially is increasingly strategic in its input, both in terms of mission after mission, but also within each mission over time. Increasingly strategic, leaving an increasing part of the tactical stuff to the crew to implement.
Yep. Thanks, Pascal. Oz.
Hey, Kelsey. I guess a few thoughts. I'd kind of re-emphasize that bullet, the science should not be an EVA FCR position. I think there's way too many, way too many people between the science team and the crew on that, in that org chart. And I think we heard that loud and clear from Jack Schmidt yesterday, right? That, direct line of communication between, the science, whatever it is, backroom, and the crew is important. And then looking at that org chart, which I've got off to the side here, to me, anything that's science related, and if that includes EVA tools, handheld instruments, rover-based instruments, all needs to be, in one science team. And it's unclear for me, if that's the case currently. I do think, the question of, robots and rovers is a big one that I hadn't really heard discussed too much. If you're going to have robots operating while the astronauts are sleeping, or, in parallel, how is all of that data going to feed in? It's a huge unknown, I think, too. And then back to your earlier throw out about themes. I think that was Jen that suggested it. It works very well, has worked very well for Mars rover missions, and impacts of volcanics or volatiles kind of theme group works well. So you don't need to, reinvent the wheel. So that kind of idea, I think, would be a good one.
Thanks. I want to come back to that, Oz, on the next topic. So keep that in mind too. Okay, I'm just going to take a couple more, and then I want to get into the next gen and the broader lunar science community, because then we got to move on to the structure. So Jackie, Katie.
Thanks, Kelsey. I definitely agree on the evolution of the team and making sure we're open to seeing what is out there and evolving as it goes. And really think having a science manager in charge of the science evaluation room or the science evaluation center can do the coordination of the different experiments, the different science teams, to get that single point of contact back to the flight control center while leaving the working level people still talking. Just so we can emphasize that, science really needs to be integrated with the EVA hardware, since those are EVA tools, the EVA suits and constraints, because you don't want two timeline differences where you want to extend or because of a science issue, but you have a suit issue that doesn't allow you to. So that's why we really are pushing for the integration of the two teams so that we can go forward on one good plan versus having to have detailed discussions in the thicker of which way to go because the science and the suit aren't in the same area. And that would lead into having that same science manager can then feed into whatever robotic controller or mission control that owns the rover that it's going to be controlling it. Sorry, and one last thing. I just want to make sure we realize that desert rats and everything were great analogs, but they did not have a lot of time critical decisions, suit leaks and things like that you really have to deal with when you're out on an EVA.
Okay. I want to get to the next gen involvement and the broader lunar science involvement because that was something that our headquarters colleagues really wanted us to address. So really quickly, any suggestions for ways to facilitate either of those, next gen or the broader community? Cindy, your hand was up first. Do you have a comment on the next gen and the broad community?
No, actually not. I didn't. I had a comment about the team structure.
Okay. We'll come back to that if there's time. Zach Morse.
Hello. I just wanted to throw in real quick that during our CanMoon analog mission that we talked about, that was essentially just a big, huge part of it was a large training exercise for early career graduate students, postdocs, that sort of thing. And so a couple of takeaways from that was that we actually had to train additional students during our first weeks. So experience hands-on the controls, like in the room, is invaluable. And I think that both training programs sort of like the CanMoon experience and Dr. Krang's flight control room flight school sort of program would be invaluable. And also I would advocate for the potential of seats in mission control for flight control apprentices, or like dedicated seats for early career folks who could sort of shadow more experienced people and get that hands-on experience. And also potentially act as documentarians, since we've seen that actual documentation by people in mission control in Apollo has been useful 50 plus years later in planning for future missions.
Thanks, Zach. Jim Head.
Yeah, I think this is really a fundamentally important opportunity across the boards for education. So there's no reason why this all can't be total engagement. Okay, so there's two things we need to do. We need to use it for teaching, and so we need to have geological exploration exercises for each EVA and have someone on the team have a responsibility of getting that out in real time to people so that, classes in geology all over the world can participate. There's no reason why that can't be the case. So that's huge from a outreach, but more importantly, next generation point of view. They can participate in these missions. No reason why not. The second one is just general outreach. We should have somebody who is responsible for commenting on the geology in real time so that, in fact, everybody across the world can be engaged in these things. So those are two things, both the geological exploration exercises and verbally annotated real time that we really need to do. And that will help really bring tons of people into the system across the planet.
Yeah, thanks, Jim. I like the concrete suggestions. Thanks for those. Noah.
Yeah, thanks, Kelsey. I think one thing about the next gen involvement we have to be careful about, though, is we may have a limited physical space, and so we can't fill it with twice as many people that will be in the room. Not everyone can have a deputy. There's going to be a lot of the buildup, and so getting that next gen in, not just the day of operations, but the years and months of preparation ahead of time will be very important. So this may not be something that every role is filled on the day of the EVA, but in the build up, the lead up as well. So I think it's not, it starts now, essentially, is that next gen involvement. And to your second point, just to try to fill in more bullets for you, broad lunar science community involvement, participating scientist programs have been very helpful. It depends on how NASA is going to organize the call for instruments, leadership for all of these things. But by recognizing that at a point, we'll know, hey, we need extra support in X, Y, Z things, particularly if these teams are selected before a landing site is selected and a particular expertise is needed. There may be a need for a call for, hey, we recognize we need additional support in volatile studies, what have you. And so reserving the funding, the time to put out those calls, select the expertise that we know we'll need when we finally get boots on the ground will be important. So, thanks for jotting that down.
Yeah, thanks. And thanks for helping me fill in my bullets. Okay, I'm sorry to do this because I know that there are a lot of hands up, but we have so much to get to. So please feel free to drop in your suggestions in the chat and I promise they will make it in there. So let's move on. And if there's time at the end, we can come back. Let's move on to science team structure. So I dropped some notes in here. Again, going back to sub-teams, Oz brought up a point relevant to this earlier. How many people should be on each sub-team? We heard a few comments from Darlene and Oz that I'm not going to read out loud in the interest of time. I tried to jot down when I heard a position mentioned, that somebody could fill in the team. And a flight director is obviously not from the science team, but again, I just wanted to include it for completeness sake. The EVA position, the EVA science officer position, Capcom and SciComm, which let's hold off on discussing those for the next slide. provide the science lead or manager, however you want to call it. I've heard imaging needs for imaging teams, for real-time mapping teams. Oz brought up the need for an integration lead, which would straddle kind of like the strategic and tactical level of decision making. Dean brought up a bandwidth director for competing data needs. And then I tried to include here like pathways that these positions will need to coordinate among. So that's, the crew to the whole flight control team in general, the flight director to the science team to the rest of the EVA system, the science team to the instrument teams, and then within the science team, these are all kind of like areas where we need to identify positions that need to be staffed. So put your hand down if you had your hand up for the previous question, so I can try to manage all of this, please. And with that, I'm actually going to try to get new voices that we haven't heard. So Kevin, let's go to Kevin next. We'll come back to Cindy.
All right. Yeah. So I'm not sure whether this falls into integration lead, but when we were doing work for ISS, it was really important that we had an ops person who really had track of all the scheduling and coming up activities, so that as they're trying to figure out where to go next, that person was able to say, hey, you're going to be pushing up against this activity, you're going to push you up this time, or their resources and other things. So that was really valuable. And also we had an engineering seat for if anything went wrong, or there was a problem, or they knew the MALs resolutions, and so they can quickly go to someone on an engineering seat that could provide information right away, or go hunt it down while somebody else was working these other sort of change activities.
Thanks, Kevin. And that's actually incredibly relevant to some lessons learned from yesterday. So I think that ties together all of these dialogues really well. Again, let's talk to some new people. Cindy, comments.
Yeah, so because, again, going back that there's going to be different modalities for doing science. So there'll be EVA science, there'll be HAB science, there'll be robotic science. So, and I imagine that there will actually be backroom structures that are relevant to each of those different modes. And then I think that there's going to have to be also a way to link those different science teams. So having liaisons between an EVA science team and a habitat science team may be really important.
Yeah, thanks, Cindy. Ernie.
Yeah, hey, Kelsey. So my thoughts here is that we've been out in the field. There's two different ways to kind of gear how we're looking at things, either by what the overall geologic objective is, which could be multi-instrument, could be included in finding out or solving that geologic problem, or it could be the deployment of a single type of instrument. So I could really see these teams being structured in two different ways. One was if you have a particular instrument or particular type of sample you're getting after to answer a very specific question, you have essentially an instrument specific team, versus if it's more an overarching question that actually involves multiple instruments or instruments and sampling, you may have like an objective type of lead that filters down to the pyramid, where beneath them are the individual instruments, folks, point of contacts for those instruments, because the overarching person would then have the overall objective and how we're going to solve that, what type of data is more important or more critical to answer that question, as things may or may not have to fall off the timeline. So I could see us slightly two different ways of structuring it from the geologic science backside.
So are you suggesting, Ernie, a structure that evolves depending on the specific traverse objective?
It would be, if the traverse objective is, well, I don't even know if you could water it down into traverse, because I think it would be more what's a scientific objective, and if there's multiple scientific objectives on a traverse, if one is multi-instrument dependent, you would have an objective lead with the science instruments underneath, versus if one is simply instrument led, it's led by what the instrument team has to say. I don't know if I clarified that or not. I can.
No, thanks for the comment. And I think Alex asked a question in chat. Is the team divided by objective, instrument, or science discipline? I mean, I think that's what we really need to get at. So I think that's where eventually we need to be able to have answers to.
Yes.
Oh, sorry. Go ahead. Okay, Pascal.
Yeah, quick question. Are you also wanting input on how the roles among the field crew would be distributed as well? Because I have some specific thoughts about that, or is this strictly about the science team structure on Earth?
science team structure on Earth. But yeah,
Okay.
good point. And perhaps that's a conversation for a later workshop, Pascal.
Yeah, although I do want to point out just this one point then. If there is first of all, are we thinking of just 2-person EVAs, 3 or 4? As soon as you get to higher numbers like 3, 4, 5 people on EVA, we've been implementing in the field the notion of traverse lead, where there's a person who might be a geologist, knowledgeable about the science agenda in full, but at the same time, some person has to be in charge of real-time situational awareness of the entire field team and what they're doing and who's closest to what asset, the vehicles, the comms, relays, this and that. And that, in case you have a comms dropout from the Earth, all of a sudden you have to transfer authority for both safety, but also just for continuation of the science to somebody who's on site.
That was the role of the commander in Apollo.
Well, that's right. That's right. But it was easy to do when it's just 2 people. If you're dealing with a larger team in the field, like 3 or 4 people, it becomes quickly a bigger task. Yeah.
But if there's a commander, they need to understand that there's a commander. That's relatively easy to do.
Yeah, but let's move away from the crew breakdown conversation. It's not that it's not important. We have so much to get through and only an hour to do it. Oz.
I guess it's a clarification on the previous points about instruments. To me, there's a fundamental distinction between, an instrument that's on a rover being operated from Earth by the mission control team to support the astronauts versus something that, is handheld instrument that, has been talked about a lot. In which case, is that, the astronaut on the surface of the moon choosing when or where to use that XRF spectrometer. The conclusion and the end result here will be very different depending on what type of instrument and where they should be placed in mission control too. I don't know if you have any thoughts on that right now as to what instruments we're talking about here, or if it is both.
Yeah, and the problem for our conversation today is that we've been asked to consider like the entire Artemis program, right? So like the answer to your question could be wildly different depending on which mission in the mission, in the overall program we're in. So we need to kind of consider the entire trade space, which makes the conversation we're having here today incredibly challenging. Not to put him on the spot, but I think it's important. The distinction that David and Cass were having in the chat is, I think, an important one. Cass, are you willing to elaborate on your point a little bit more? Okay, or not?
Hello, sorry.
Oh, great.
Can you hear me?
Yes.
Hi, everyone. So it relates to sort of what we learned in CanMoon and in previous missions. You can't have the science lead that is, involved in tactical decision making, also making interpretation decisions, which is why we split that into 2. You've got one science leader, whatever you want to call them, that is, involved in tactical mission control, and then a separate, independent of tactical operations scientist, another science leader or manager, whatever you want to call them, that is directing the overall progression of the long-term strategic planning. Does that make sense?
Yeah, thanks. Thanks for that. Mark, Reagan.
Hey there. So I keep coming back to thinking about how our payload ops work on station, and we have a payload ops director who runs this team. That's a science team, but the team he runs is a very ops-oriented team. They have the planner function that we just wrote down a few minutes ago, and they have, tentacles into the different kinds of science and the different kinds of vehicle systems requirements and all of that stuff, and they really understand how to make the ops work for this. And the payload ops director, who is basically a counterpart of the flight director, and the flight director ultimately has final authority, but the payload ops director is a counterpart, most times, and what they do is decide, take all of those inputs for all of the different competing science objectives and all of the different resources they need and all of the different plan, gives and takes they need, and they represent all of that and make sure it gets rolled up into something executable, and they speak for the team. And I think, even the terminology, the payload ops director, is different than a science lead. It implies something much more authoritative, and it implies somebody that's enabled to go off and make this science plan happen day by day, much more than a science lead does to me. So I would throw that out there for consideration. The thing that's strong about that is there are people that, their day job is ops. They represent those payloads and they understand the science, but their day job is turning it around so that it's operational and executable every day. And that's, I think, why that is a successful model.
Thanks, Mark. In the spirit of new voices, Jessica.
Hey, yeah, I just kind of have a general thought. It's not really a suggestion, so it might not be super helpful. But I'm just thinking about the actual interaction with the crew member, and I think that interface is going to drive the rest of the structure of the science team. And so, thinking about exactly what needs to get fed back to the crew in the moment, during the EVA. I think one big difference potentially from, well, maybe it's not a big difference, but one thing to consider is this idea of this flexecution term, right? So how much autonomy is the crew going to have versus, given all of the data that we have for the moon and our capability of designing a really really well thought out, detailed plan for an EVA, how much do we expect a crew member to just go out and execute the plan that has been developed for them versus how much do we expect the crew member to really be kind of exploring and thus needing and expecting interaction with the science team. We kind of touched on this yesterday, but if a crew member really is mostly just executing the plan that they are well familiar with, well versed in, the interaction with the science backroom during the EVA itself will actually be relatively minimal unless a crew member finds orange soil. But for the most part, what we're talking about, I think, is really having a science team that's kind of monitoring what's going on, documenting it, obviously analyzing that data, but how much ability will we even really expect to need to be able to interface with the crew in that moment in order to change the plan going forward for the rest of that EVA.
Yeah, thanks for that perspective. Yeah, so many variables to try to constrain, and I think we've heard a lot this week that we need a lot of practice to be able to do this, and perhaps that's what we need before we can really nail down these roles and responsibilities. Noah.
Yeah, I don't really feel comfortable talking after Jessica, so I'm gonna let that just sit out there for a moment. I think the one thing we have to, there's things that we want, and then there's a reality of how it's going to be. I think the reality is that we want the Capcom to be an extension of that science group, as was in Apollo. Bob Parker was a science lead. We want that person, however, to be in the communication backroom to crew, however it's going to happen, to be as clear. So when Jessica finds orange soil, she has the autonomy to do what she knows as the science lead. I use that phrase very, very specifically yesterday, the field PI, to say this is the most important thing to go after right now, and we're going to go after this. One caution, I'm getting a little lost in some of the terminology that we have going on in the chat and what's being captured here. Cassandra and David's phrase. I think Kelsey, when you write this up, it's going to be very dangerous to completely verbatim go from chat to this. And so I hope that everybody who's participating has a chance to make sure that we're clear about what we mean. And I'm looking at Cassandra's comments, and terminology is going to get a little bit messy here because I think there's some phrases that are being used in different ways and different by different people. But ultimately, in terms of structure, having a single person as the science, between the instruments, the field observations, the sample collection, who is ensuring that the plan that's developed in the years and months leading the mission sees that it's done as rigorously as possible. Crew is going to be a big part of that, as well as all of these people that we're defining in the science team. So just a word of caution, though, Kelsey, that we're going to have to make sure that everybody who's had some input has a chance to make sure that the write-up is capturing the multiple terminologies that we're using here.
Yeah, and frankly, one of the asks from this workshop is to start to define that terminology. So, yeah. I want to interject and ask Tess if there's anything from the chat or anything else that you want to bring to the table, Tess.
Kelsey, I think you've been doing a great job of pulling things from the chat.
Okay.
So I don't have anything to add at this time, but I'm keeping an eye on it.
Okay, just checking. Thank you. Okay, I'm going to call on Oz, but while he's talking, I want to encourage those of you who have not yet spoken up. If there's any input you have, we definitely want to capture everybody's opinion. So while Oz is speaking, think about if there's any more contributions on the science team structure, and then we can move on to talk a little bit more about comms. And the other ask, to put Oz off even more, sorry, is think about if there's any positions that you guys kind of either heard over this week or you want to bring to the table that we haven't yet captured in this list. I mean, obviously, we're going to need a lot more conversation to figure out how all of these positions map together. But just in the spirit of like getting all of the options onto the table, think about if there's anything we're missing. Over to Oz.
Thanks, Kelsey. Jessica's comment just made me think of something Jose said earlier in his closing talk, I guess. Is the science team back on Earth going to be, just there for support if the crew needs them at all? It might be the case that they don't, or I think Jose used the term, is it like the third kind of a field team member? You're going to have one or two people in the back room who is almost there, with the astronauts in real time on Earth for, just bouncing around. If you've been in the field with people, you kind of just bounce around ideas and banter as you're going along, and that would also, change how you structure things, and the need for maybe part of the science team to have, direct communication with the astronauts. Maybe the astronauts don't want anybody else in their ear.
Yeah, thanks, Oz. Ashwin.
Hi, everybody. So just a comment about tactical versus longer term planning. So on the Mars missions, this has been a huge thing for us because we do plan over a tactical timescale and then up to multi-year timescale. And we found that I guess two things. It's too hard to describe in a 30-second comment here. So definitely offer to give a dedicated presentation on that at a future workshop if that's helpful. But just, the very brief summaries that we do plan over the day's time scale, the week time scale, and the year time scale. And those are done by independent teams. Of course, the day time scale is the one that's really on the front lines, but the different teams planning at kind of the week and year time scale, meet offline in their own ways and have ways, we've developed ways for them to feedback interactively with the tactical team.
Yeah, thanks a lot. So perhaps we even need more resolution than just tactical versus strategic, is what you're saying.
Yeah, for very long missions.
Yeah, absolutely. Okay, moving on to the last topic, and we have about 17 minutes left, is comms. So I wrote just a few notes down over the course of the week. How should the science team interact and communicate, like within the nexus of the science team during a mission? How does the science team communicate to the crew? The differentiation between SciComm and Capcom. Let's maybe start there. And then we also want to touch on who has the final decision-making authority on science decisions. So I know people have been waiting patiently to have the Capcom versus SciComm conversation. So soliciting feedback on that. Ernie Bell.
Okay. Kelsey, actually, I wasn't going to comment on
No problem.
Capcom versus SciComm, although I do have an opinion on that. I can start with that. From what we experienced in Desert Rats, I can see the SciComm being very similar to a ground IV position that we use for EVA. So I don't see that I see that it would be beneficial to have. But then again, that also depends on the size of the crew. If the crew is very, very small and everybody's out EVA doing the same thing, you may not actually need a separate SciComm or ground IV position. But I can see it being comparable to the ground IV type position. What I was actually going to comment about regarding comms, though, was, and I mentioned it yesterday a little bit, is are we going to talk purely voice right now, or really communication is beyond that? It's telemetry, it's commanding, and those two things have a significant impact on how much voice communication needs to go up and down, and the ability to get, command ability or telemetry down will actually obviously drive how much assistance the ground science team can actually provide. So I'm not quite sure that I have a recommendation other than we need to keep those all aware that it's more than just voice. It's all three of those types of items, I think.
Yeah, thanks a lot. And that is specifically, the other breakout has been specifically tasked to think about that. So I'm glad to hear that others think it's valuable, because that was one of Jose's main talking points for the other breakout.
Okay. Yeah, it's hard to know which one to go to.
Yep. No, I hear you. Thanks for the feedback. Mike Evans.
This discussion is an evolution of success. Chris Kraft and Gene Kranz initiated the Capcom to isolate all communications with the crew to keep from confusing them in the early days of ground flight control. We have 50 years of experience now, and we've migrated away from that. We've demonstrated on ISS that with complex science, especially in IVA, it is easier to have the PI or a knowledgeable scientist directly communicate with the crew. Like if you're doing DNA sequencing or you're in the middle of some type of a complicated task with many, many intricate steps, it's easier to have the crew communicate directly with the science lead than to have to educate the Capcom on the procedure steps and then have the Capcom try to talk the crew through it. We've demonstrated that successfully. I think this is an evolution of how successful we've been in flight control. But the original Capcom function was also realized that the science that they were doing 50 years ago was much simpler. So I think there is clearly a migration of success here, and I adamantly believe direct air-to-ground loops between SciComm and crew, or whatever we're calling it, as needed is appropriate.
Thanks, Mike. Alex.
Yeah, I think that like we're all saying that we want an expert in the field to be able to communicate to the crew members. I agree. I don't like the word SciComm because it sounds like that person's only science focused, and they shouldn't be just science focused. They should be mission focused, mission success focused. This person has to be an advocate for the crew member. And so I think going on to what Jessica was saying is, we can't have it both ways of autonomy versus not autonomy. If we really want the value and we really want our eyes forward of making experts in the field, we really have to educate those crew members to make those decisions, because they're going to have way better SA than we are. I know that people are expecting these amazing views and this grandiose camera because we have better technology, but we're going to the South Pole and it has terrible lighting. And so I don't think, just to set our expectation levels, just with recent testing, we're not going to get these extravagant views, on that first mission. And so being able to educate our crew members on how to make those autonomous and real-time decisions in the field is very important. I think that ties into, all right, we really got to get the funding to train our crew members. I also want to play in that 8-second time delay. That's another thing that we have to think about of, the back and forth and the efficiency in the comm.
Yep, thanks, Alex. Pascal.
Yeah, I wanted to echo what Mike Evans said earlier. I completely agree. But a point I wanted to bring up is one thing that was really well done in Desert Rats, among many other things, were sort of the debriefs after the EVAs. And in those debriefs, the crew was able to interface not just with whoever was the science comm or the science lead, but actually in some sort of a dialogue with the broader science team that was on site. There's some merit to being able to do that, or at least experiment with that. Maybe without baselining it, we could contemplate the idea of having, say, a 30-minute chat, sort of an open mic chat, almost moderated, obviously, by maybe the science lead or the science comm, with the crew at the end of an EVA, especially if you have an opportunity to return to a site or the option to do that later in the mission or on the program.
Yeah, thanks. I'm really glad you brought that up, Pascal. Thanks. Jackie.
Yep, thank you. Sorry, most of my things were said by Alex, but again, just to partially agree with Mike Evans. I agree for IVA ops, having that payload person and direct communication with the crew is important. But for EVA ops, our success over the past 30 years of EVAs shows that we need to stick to that isolation of the crew member to a single voice in their ear, so that there is not confusion and so that there's no conflicting information, especially in times of at risk or very active times.
Yeah, thanks, Jackie. I'm going to skip to a new voice who's raising their hand. Misbahar Rehman Saad, do you want to chime in?
Yeah, I just wanted to comment on this thing is that I think we should really focus on the initial EVA scenarios, because right now we are discussing IV scenarios or robotic scenarios and all these scenarios. And I think as we will evolve, as we go forward, we will find solutions for those things. But I think at this point, we should really focus on the initial scenarios of what it will be, the initial EVAs will be, and what will be the best configuration for those. And that will allow a bit of other chatter to settle down, and then we have a focused point to think about. And I kind of agree on, at least in the initial scenarios, to have a single voice thing. But I also come from the FCT, so it's a biased opinion.
Thanks a lot. Ashwin, did you still have your hand up, or is that new? Sorry, I can't keep track.
Forgot to turn it off, sorry.
Great. Okay, Mike. And while Mike is talking, just want to encourage, we're coming up on the last 8 minutes. So any other folks who haven't spoken up yet, please feel free to do so. Go ahead, Mike.
I'm sorry, I'm done. I've said what I need.
Oh, okay. John.
Yeah, I was just wondering, it seems like we're all talking voice loops here. Since the Apollo days, we have another tool at our disposal called email. And we're in the middle of actually doing autonomous grow out for a veggie crop, and Hopper is actually emailing our plant scientists directly, CCing, of course, programmatic people. And that is another lines of communication that can be done. It doesn't have to be real time, but it can solve some of the problems. So.
Alex, thanks, John. Over to Alex.
Yeah, I know the other group's talking about data and email, and I just wanted to let you know one of the technologies that we're developing in the suit is to be able to text the crew member, because we find that's going to be a lot more efficient with the comm delay. We've already done a lot of testing with comm delay, so great point, John, and agree, we're working on it.
Thanks, Alex. At this point, with only a few minutes left, any of our headquarters colleagues have any questions, like specific go backs, want to pull on any threads that have been said, want to allow them an opportunity to refine the conversation? Any input from any of them? Jake, Sarah, Ryan, I'm probably missing people. Okay, while you're thinking about it. Okay, so any other, at this point, I think with 5 minutes left, any other kind of go backs or thoughts on any of the topics we've discussed? I hated to cut short, especially the next gen comment discussion earlier. It seemed like there were a lot of opinions there. So any kind of go backs or final thoughts on this breakout topic in general? Ernie.
Yeah, Kelsey. The very first thing we talked about regarding front room positions. And it seems that you guys are testing right now that essentially an EVA science position will be parallel with task and systems, and that seems like a fine way to do it. But I would also suggest that we don't completely rule out the idea of having a front room type of position parallel to the EVA FICR. Just take a look at it and see if it would work. My recollection, and somebody correct me if I'm wrong, because my recollection of history isn't great here with Apollo, but it seemed like it was that the folks worrying about the suit systems were different than the folks in the front room that also were coordinating the task, but I could be completely wrong on that. So somebody correct me if I am, but I would not completely rule out the idea of having a front room, essentially science task type of geoscience task type position, and just see it and see if it works. And don't bias it, try it, coordinate it with the EVA systems, EVA lead FICR at that point too, and see if it works. Just an idea.
I could comment on that relative to your question, if you have time, Kelsey.
Yeah, shoot, Jim.
Okay. So the deal is, so in mission control, there were people who were the top of the pyramid of each of those areas, suit, rover, et cetera, et cetera, et cetera. And they had a backup room somewhere in mission control or elsewhere on the campus of JSC. And so, they basically were listening in on what their team was telling them. And I agree with you that there may be the possibility of elevating the science support room to that level and have it be, when they go around, like when the flight director says, "Or we go for landing," ops, they go through the whole thing, and then one of those could be science. So let's think about that kind of structure as well.
Thanks, Jim. Okay, last call. Okay. I am going to attempt to distill these into some sort of digestible 5-minute spiel for the wrap up in the WebEx. Apologies if I do not adequately represent everything covered in the discussion. However, I do have one more ask of all of you, and that's that you continue to engage about this topic. Jose and I and Tess and Zach and everyone are going to try to coalesce all of these thoughts into reports. Jose and I are also strategizing about the best way to continue the dialogue, because an hour is clearly not enough time to be able to really move this forward and capture enough input. So I guess my plea to you is to continue to stay engaged when we upload the draft reports, as well as if Jose and I wrap our brains around a way to continue to facilitate input after today. So I guess, the ask is continue to stay engaged, continue to provide input, and Jose and I are going to try really hard to represent the interests of the entire community, but we really welcome continued dialogue, and please don't hesitate to reach out. So we have 3 minutes. Please make your way back over to the WebEx, and we'll hear how the other breakout went, because I think there are a lot of touch points between what we were talking about and what I think Jose was coordinating. Thanks, everybody. Talk to you in a couple minutes.
Great job of herding cats.
Thanks. That's a big job. Thanks for all your input.